Well, greetings webfolk. Today we're going to continue working out how to use Engo.io, which is the 2D game engine which was created originally by Paked, which is his GitHub handle, and a couple of others. And the aim of this tutorial is to make a game, something similar to the classic Frogger game. Apologies, by the way, you can't see my beautiful face. That is because I have been fighting with OBS. That's why there's also no video last week. So now I'm currently using Simple Screen Recorder, which doesn't have a camera. So this is what we got so far. It doesn't do a whole lot. We have a frog on a screen, and that frog looks an awful lot like a triangle. I'll show you what I've been doing, because I've been working ahead of this project, so I'll show you what I have managed to get so far, and hopefully we will get some bit further with future videos. So let's do this. And so we have a frog who can move about. We have some cars to avoid, and if you get hit by a car, then you get sent all the way back to the beginning. The other thing that I've managed to get working is a 2-player system. So if I put NP of 2, if I'll put it to 3, then we now have 3 players, and each frog can be moved by a different set of keys. Yeah, so that's the game as it is. And today, hopefully, we are going to get those cars moving in our version. So let's just take a peek at the code we have so far. Oh yeah, the plan today is to add cars and give them movement. Today I'm going to create a car motion system which loops through all the cars and moves them according to their velocity. To do that, I'm also going to need to store their velocity, which means creating our own velocity component. And we're also going to use the common space component because we need to move them around. And so that's what the system is going to receive. And obviously we're going to need a spawning system because cars won't move unless there won't be any cars unless we create them. So first things first, let's look at the code we have already. So here's our main function. We set our options to engo.runOptions. So we create one of these and we set these. So we got this. We got our main, our options, and then we just call engo.run and we send it a scene. And where does that scene come from? Well, we have our folder called play, and in that folder we have a file called scene.go, which provides our scene. A scene needs to have a type, it needs to have a method called preload and a method called setup. That seems to be everything it needs to be a scene. And in the setup we receive an ECS world, are pointed to it, so that we can add things to that world and change some things. So here we go, we can add systems to the world, and here we already have a render system. We needed to have a render system because without that it won't draw anything. We've also got our frog, which is called new frog, and we added that to the system by all of its parts. So we had to add the basic entity, the render component, and the space component belonging to that frog as pointers to the system. Now, this doesn't come with Engo.io, but I found it incredibly frustrating having to write frog and frog.basic entity and frog.render component and frog.space component every single time I wanted to add something to the render system. I'd have to add all 3 of those parts. And so what I've gone and done is to every one of those components in Engo.io, which isn't, I have added my own, I've added a method called getThis. So the basic entity now has a method called getBasicEntity. And then I created a method which doesn't exist in the original thing, but I've forked it and I've created it, and hopefully they will think to accept this. So So instead I can write this. Because frog already has a method attached to it called getBasicEntity, which returns a pointer to a basic entity, and because the component BasicEntity has that method, it's naturally inherited by the frog, and so is getRenderComponent, and so is getSpaceComponent, and so this should still run, and it should save me a ton of work. So we still get the frog. Now, in order to use this, you're going to need to use my version of Engo, which I didn't really want to do. I'm really hopeful that this will be accepted by the maintainers of Engo.io, because I don't want to end up maintaining something else. But if you download that, you can always get this one from me at github.com/coder/convoy/Engo. And I've also done a fork of github.com/coder/convoy/ECS, which are the two main libraries you need to have this working. But that just means that when you go to add something, you can use the addByInterface method, and you only need to remember that it's a frog. You don't need to remember the order of all the parts you need to add. And actually, it's quite a scalable system too, because you can each component has its own method you write, which is get this component, and then naturally the container of that component has the method get this component, so it satisfies the interface needed for these things. So I hope you find that helpful. If you agree with me, tell the people at go to github.com and support my pull request. If you think that that's a really bad idea and I'm completely missing the point of ECS, then also make a comment on my pull request, or leave a comment on the bottom of this video so that I know your thoughts and I can see what I'm thinking. But basically that meant one extra method added to each system, and one extra method added to each component. So it is a bit more work, but when you actually add stuff, so much simpler. So the next thing I needed to do was to come up with a system that creates cars. So let's make a spawn system, shall we? So if we tab edit, play, and we'll call this spawn.go because that's what it's after doing. Package, play. Another thing that I finally managed to do is I've got Go imports working properly in this. That will make my life a lot simpler. So I won't even bother writing the imports that we need anymore. I'll just let this work it out for me. So we need to create a struct called spawn system, and our spawn system. Oh, this is supposed to be a struct, and a spawn system needs to have the same methods as every other system, which is a remove and an update. So func, and this takes ss pointer to a spawn system, remove, and that takes C, which is ECS dot basic entity, and it's not a pointer. I was surprised by this, but and of course we only need to do that. Look at that, isn't that so fancy? There's Go imports on save. Anyway, carry on. The other thing we need is spawn system, and this is update, and this takes a D. It's normally D for delta time, change in time, and that is a float 32, as most of the stuff in Engo is to do with screen position and time. So that D will be the amount of time that has passed since we last did any spawning. The other thing we are going to need, it needs to have access to all of the components, the systems it needs to add the things to. My solution to this, not the official solution is to just go through the world and find all the systems of the right type. But I feel like sometimes you might actually want two systems of the same type, and I want to know that I'm adding to the right one. So I'm going to do it slightly differently. And I'm going to have a struct type, and this is syslist. And realistically, not all of the systems need to know about this. Only the spawners and a couple of others need to know about the other systems. So sorry, that's a struct. Got a bit confused there. And the syslist will contain a render system. And actually we need to give these names, so I'm going to call it render sys, and that's a render sys. So our update function for now will simply be since colon equals, oh, we need that as part of our since, don't we? Since float 32, and that will naturally default to 0 when we create it, won't it? So I don't even need to update that if I don't want to. And here what we do is we do since colon equals since plus d. If since is greater than, I don't know, we'll add one every second, right? So time 1. We'll do that for 1 is a second, I'm pretty sure. Then we need to set since back to 0. Oh, and this is obviously ss.since. This is me not quite paying attention to what I'm doing. So, and the other things we need to do is we basically need to create a car. I feel like I want to have cars in a different file, so I'm going to do tab edit play cars.go, package play, and now we need a type, which is a car, which is a struct, and that struct will obviously need a ecs.basic entity. It will need a space component, which is engo.space component. It will need a velocity component, which doesn't exist yet, so we won't worry about it right now. We'll add velocity later. It will need that for now. Oh, it needs a render component. Those three things ought to do everything. Those three things allow us to put a car on it. It looks a lot like a frog, doesn't it? If we look at frog, here it is. There's a basic entity, a render component, and a space component. Cars will behave differently to frogs, so I will have to change that later. And you can save that. And then, so here's what we do: C colon equals and car and ECS dot basic. Do I need the ECS there? Do I just write basic entity? Entity. A new one, doesn't it? So ECS dot new basic. Then the space component. And that becomes a new space component. And what does that space component contain? Well, I'm not completely sure right now. It needs a location, position, capital P. Position will be engo.point. For now, let's just make it 300, 300. That will mean a lot of cars appear in the same place. I think it has a width and a height. Width colon 100. Height colon 50. Right. 17.2 spawn.go. Yeah, you can't do that. That's not a new variable. Okay, so what I did there was I had a colon equals because I always write colon equals is, and it's not a colon equals because it's something that already exists. So we've made our new space component, and the last thing that it needed was a render component, right? Render component, and that's an engo.render component, and a render component needs a drawable, and for this I am going to say a drawable. We'll do a rectangle, yeah. Vaguely got to remember how this was done, but I'm pretty sure it's the same as how you did a triangle for the frogs. So just put a common dot triangle, so common dot rectangle and color dot black ought to do the job. Rectangle and color just for now. We'll set the colors a bit different in a second. Oh, and we're missing a comma here, which allows us to close up that car. And once we've made our car, we can add it to all the systems in the sys list that we store somewhere in here, and that's pointed to syslist systems, and that's a syslist. So when we make our spawn system, obviously we're going to need to set that syslist, and we're going to need to set, well, we don't need to set synths, but we do need to set its systems. So that's okay. Ooh. And that's okay. So now what we're going to do once we've done this is we're going to add our car to the syslist. So we do sys ss.systems dot render sys. Was it capital R? Yeah. Co dot add by interface. Remember, this is something that only exists in my fork. If you want to do it using their fork, you're going to have to write add. So I'll show you how you do it in the original. It's add c dot pointer to c dot basic entity pointer to c dot render component pointer to c dot space component, and that will do it. I'm going to do it this way because it's easier. And so now we've added the car to the render system. We should find cars appearing about every second in the middle of the screen. For the sake of tracking things, I'm going to putncars, and that's a int. When we do this, we do ncars plus plus, and then when we set their position, we will set it to float 32 300. Oh, plus 10 times ss dot n cars, and of course this is ss dot n cars. That should mean we get some cars appearing on the render system, but only in the render system when we run this. Let's see what all the errors we get are. Plenty of them to start with. 7. Engo is not a package. Yeah, it is. Cars. Oh. Common. It couldn't find the things I wanted in that package. There we go. So now we've only got one error left, and that is a 12. Oh, did you notice that it's going much faster this time for the actual builds? That seems to be because once you've done a build, it seems to hold it, so it's worth keeping a pre-built version. I have no idea for sure if that's what changed, but it has been much faster since. So spawn.go, line 12. Oh, spawn.go. 12. And this is, of course, common.render system. Spawn.go 26. I also noticed... Oh, there's a since there. That's line 26, isn't it? 32. Undefined engo.space component. Again, same problem. I just thought engo, but they're actually common. So that should fix that. Type common.rectangle is not an expression. Oh, because of course we need the squiggly braces to say that it's a type. And it runs. Now there aren't any cars coming. I realized this while I was trying to go through the bugs, because obviously we have only made the system, we've not created it. So let's do that. Back to our main. Not in our main, in scene. We now need to create that new system. So we'll use a syslist. Syslist. Systems : equals syslist. One of these. I might actually make it a pointer. Oh, of course. Render sys. What's it think is missing? Missing comma before new line. That's easy. Okay, so now we've added that system to a syslist. When we make our spawn system, spawn sys equals, and then we need a spawn system, and of course the syslist, or systems I think it was, systems becomes I cannot type. And rs no longer exists, so now we need to write systems dot render sys, and the other one we're going to add is, of course, spawn sys. And that is miles off. W dot add system spawn sys. So now we've added the two systems. The spawn system knows about the render system. It doesn't know about any other systems. When it creates cars, it will throw them on the render system in every update. So in theory, cannot use common.render system literal type pointer to common render system as type common render system. Aha! So my syslist, which is in the spawn folder, wants to store a pointer. 24 undefined spawn system. That's fine. Oh, that might explain most of my problems. 27 undefined rs in rs.addByInterface, because rs is no longer in existence. It is systems dot render sys. 30 cannot use spawn sys as type ECS system in argument to w.add system. Can I use spawn sys? No, it can't, but maybe it can add a pointer. There we go, and we have cars being created ever so slightly further along. As we look here, all of these cars, there's a new one coming every second. So, progress, we have cars. Now, time to add a new component called a velocity component to our car. Basically, it's going to store a point. It doesn't need to be a point for this game, but I think I am going to leave it as a point for various reasons. So, sorry, I get confused. Package, and let's just play. And we're going to add a type, velocity component, and that's a struct, and that will store engo.point. And that's vel. And this will need some properties. The first one, to fit with my system, the thing, is we're going to need to give it a method. This takes a pointer to a velocity component, get velocity component, and this returns a pointer to a velocity component. Throw these down, and we'll do that there. Return v. Okay, so this doesn't do a whole lot, but that just makes it so that when you include a velocity component in the frog or in a car, then the car naturally implements the method get velocity component. By implementing the velocity component method, we get some extra benefits. We can just do add by interface more easily. We can add that to our car. Velocity component, And now we need our movement system, which will be in cars.go, which is this one. Oh. Type movement. Can I spell? Ment system struct. Is it a struct? Yeah, why not? And this needs to be a system, and systems have two important methods. One is remove. And this removes and because our struct here is going to contain a list of movement entities, I guess. This will basically explain how most of these systems work. We have type movement entity, and this needs a pointer to ECS.basic entity, and these do need to be pointers because we're receiving copies of the objects we need. We'll also need a pointer to a common.space component, and we'll need a pointer to a velocity component. Do I need commas? Don't think so. Oh, struct. Okay, now that we've got our movement entity, our struct, our movement system. Is that how you spell movement? It feels wrong. Our movement system will now contain an array list. Not an array list. Look at me here talking JavaScript. No, Java. We'll need a slice of movement entity. And we also need that func for ms movement system, and this will update. I'll write this one first so we can see what we're going to do for how the rest of them work. Because this one's really straightforward, right? You go for underscore comma c colon equals obs range ms.obs. So we just loop through all of the cars or other objects in the movement system, and these are movement entities, so we can do c dot. I might give these names actually. No, I don't. I don't even need to. C dot position dot x plus equals c dot val dot x, c dot position dot y plus equals c dot val dot y. Oh, and of course we need to times that by d, which is a float 32. Times by d. So the update system is pretty that's pretty straightforward. The removal is slightly trickier, but basically you're just looking for it and pulling out of a slice. And the add system, which will be slightly easier, we'll do func ms pointer to movement system. And we don't. I'm just going to write add by interface. No, I'm going to write it how it is done how they make the systems, how the Engo people make their systems, so you can see how that's done. BE pointer to ECS.basic entity. What the other things we need? SC is a pointer to common.space component. Common is of course a package that is part of Engo, so it's actually a sub package of Engo, in case you didn't see that already. And we need a VC, which is a pointer to a velocity component. Make sense? And then obs ms.obs equals append ms.obs with a new object, which is a movement entity. Movement entity, and we should just be able to write BESC VC. So that's our add method. Something is wrong there. Missing comma before new line in some argument list somewhere. Oh, I get it. Close that bracket. So that's that did. We now have a append method. We don't have a remove method. We don't actually have a case where we need to remove cards yet, so I'm not in a hurry to do that. And this is what my func ms movement system add by interface ob, and then we need to name the interface. I could do it here, but I actually feel slightly tidier. I'm gonna create another package, tab edit play faces.go package play, and define a few useful interfaces. Basic face, type, right? Type basic face interface, and this is just ECS dot get basic entity pointer to basic entity. Type space face interface get space component. Oh, this should be ECS, of course. Returns a pointer to common dot space component. We'll have a type render face with an interface, and that returns a get render component common dot render component. One more for velocity. Type velocity face interface get velocity component pointer to velocity component. Next thing we need is our combined interface, right? So we'll call this type. Now, the Golang people, they do say you should name your interfaces ERs. So doer, maker, writer, reader, etc. The reason I'm not doing that with this, and I feel like this makes an exception, is because we're using the entity component system where the entities don't do stuff. So we get these components, so I'm actually going to use the able for the interface I need. So this is going to be move able for move, and this obviously needs the various... Oh, it is an interface. And this is a basic face, space face, and velocity face. Right. So our movable implements those three things. So I come back to our cars, and the add by interface now takes a movable, and then we just do ms.add ob.get capital G get basic entity ob.get space component ob.get movement component. And so yes, it was a little bit of extra work to add the interface that's needed to make it easier to add in the long run, but I think this is worth it. Feel free to disagree with me. I would love to hear your opinions on this change in the comments. Although, please do keep them respectful. I know what YouTube can be like. Next, the remove method. Now, I always get a little bit confused by this. The basic gist is run through, find the entity, and take it out of the list. So, I'm just going to quickly copy and paste it from somewhere else where I've already written one that's a lot like it. Yeah, so here's my remove space entity method. This removed a space entity, which here is a basic entity and a space component. So I'm just going to copy this method into my yank that. Problem is, we need to remove an awful lot of things. So I'm going to remove a move. What was it? What was it? It was a movement entity, was it? Yeah, movement entity. Entity. Obviously, this now needs to be a movement entity. But apart from that, that basically works. So here's what we do. We just... So the remove... Oh. Package play. So the remove movement entity method takes a slice of movement entities and returns a slice of movement entities with the appropriate one removed. And it's very straightforward in how it does it. It just takes a counter. If it finds the ID, it gets rid of it. And it gets rid of it by basically taking a slice from either side. I have to admit, I get confused by these numbers, which is the main reason I've copied and pasted this code, is to make sure I didn't get that wrong. I just get confused about which one I need to be removing, adding one to, or whatever. So now we come back to our movement system, and our remove method, we can call that function remove movement entity. Now I could just put that code local, I suppose. ms.obs equals... Oh. My main motive for doing it this way is because I think several systems are going to want to are going to have movement system or something similar, and the code is so the same for all of them except for a tiny part. This is the kind of thing you really wish you could do generics for. I don't really want to use reflection, so I'm going to do it the slow way. But now we've got our movement system included. Our cars do not yet now have the movement component, so let's give them a movement component. So in cars.go, the car struct has a velocity component, but when we spawn them we don't yet give it that, so here we are, velocity component, comma, and this takes and for now I'm just going to set that to... Tell you what, why don't we give all of the cars a different speed so that we can see that they are all different cars, and so we can do ran.float 32 times 5 minus 2.5. Is that fast enough? It might be. And we'll do the same for... I don't know why I've got these brackets here. That's not how it works. And the same again, rand.float 32 times 5 minus 2.5. So in theory our cars now have a velocity. ss.systems.movementsys.add by interface C. And this obviously means that our sys list needs a movement system. And in our scene where we create these, we add movement sys and movement system. Was there anything this needed? I was just an empty struct that contains the things. So obviously w.add systems dot movement sys. In theory this ought to work. Should we try it? Here we go. Cars 32. No, cars go 30. Ob go basic entity. Type movable has no field or method. Get basic entity, but does have These should all be capital G's. Cars 30. Object get movement component. There is no get movement component. Where do I use get movement? That should probably be get velocity component, hey? Cars dot go 30. Yeah, so this is movement. No, that's my mistake last time. Velocity. So that fixes that one. 34 undefined ECS dot. So that was an E. That's that, not the package. Cannot use as type. Oh, and who forgot to put the open close brackets? So that fixes that one. 39 cannot use float dot point. Aha! My mistake there was to forget to actually write Engo dot point in the car spawn. So here I was supposed to write Engo dot point, open that and close that. So now we have cars and they all seem to have slightly different velocities and they're all moving in different directions and they're starting slightly further to the left. So if you start to watch this for a little while, they're going to spawn. They're not going very fast, so it's not very clear. Let's up that velocity a little bit. Make that 20. Oh. And make this 10. And this one should be the same. Then we run. So now we get a car every second, and these cars are going in different directions according to their mood. And that is a good intro to how we can use systems in Engo.io. I hope you find that helpful. Leave me a comment on anything that's not clear. I would love to be able to help. And do like and subscribe if you found this at all helpful. See you hopefully next week, and maybe you'll get to see my lovely mug. Ta-ra till then.